multiple times a day, save 12 to 18 months of time per program, per 5-year cycle, by embracing this continuous accreditation model. And then we also save another 8 months to 18 months of time per program, per 5-year cycle, by embracing the continuous feedback loop between the warfighter and the development teams to build better capabilities. And so when you compound that, you're looking at up to 3 years out of 5 years of time saved, and that's pretty mind-boggling. We'll show you also how we got to embrace hardware-in-the-loop testing to be able to not only emulate a digital twin of the software and the hardware on the cloud, but then also bring the DevSecOps stack on the weapon, on the device, on the hardware to run a set of tests on the hardware multiple times a day, so you know exactly how the software is going to behave on the hardware as well. So a few numbers that are pretty interesting, when it comes to the return on investment with DevSecOps. On top of the 100 years of time saved, we see 106 times faster lead time from development to production, 208 times more frequent code deployments, 7 times less failure, 22% less time spent on rework, 50% less time spent on cyber issues, a mind-boggling 2,600 times faster recovery, mean time to recover. We see development cost reduced by 40% on average, and then employees are 2.2 times more likely to recommend the organization. So, it's tough to attract and retain talent, so that's a great way to do that. And so, I think that's been a great ability for us to not only attract new talent but also retain them as well. So really, the waterfall move to DevSecOps is kind of embracing this agility mindset, moving from a monolithic architecture to microservices, from often physical server and to containers. Although for us, these containers become Lego blocks, and they can run both on weapon systems at the edge or on clouds. So it's really agnostic. Gives us the ability to really reuse Lego blocks and scale across systems and environments without having to redevelop the software. Moving from a hosted to a cloud mindset, but really what we mean by cloud, we mean cloud native, because most of the software we run is going to be running on DoD hardware, on weapons, and so it's cloud native. It's not really a cloud, but it's cloud native. So it gives us the flexibility we need and the agility and modularity we need to succeed. So here, as you can see, we have this, case study between SpaceX and F-35 from 2019 before the move to DevSecOps. And so you see SpaceX had 9 vehicles, F-35 has 1 with several variants. SpaceX has only 200 developers. That includes the team to build all the AI/ML to catch the rocket back on the ground and the boat and so on. And so 4,000 developers are allocated for the F-35. Only 4% of the code was reused between F-22s and F-35. And so you would see a 50% defect, which effectively meant 2,000 of the developers were useless, pretty much. And so you compare that to the SpaceX reusable Lego blocks containerized model, where they had 80% of the code reused between platforms. So effectively, a new platform would really reuse these Lego blocks and bring the flexibility you need to succeed. And so that's a game changer. And they were able to embrace DevSecOps and update software the day before the launch. Now it's hours before the launch, with 17,000 build of software a day, and then 3 hardware-in-the-loop testing a day on the hardware to make sure they're not breaking anything on the hardware that the modeling on the cloud could not detect. And so really you compare that to a 7-year, really 1 to 7 year average on the F-35, which obviously is not enough to be able to move at the pace of elements. So that really gives us a lot of insight as far as how to do this. And so in 2019, in 45 days, we put Kubernetes and Istio, the service mesh, on the F-16 jet on legacy hardware without swapping the hardware whatsoever. So something I used to run Ada and C now would be running, C would be running now Python and Go and Java. And so that's really a massive game changer on the same hardware. So that was a good demonstration that, hey, if we can do it on a 60-year-old jet, we can probably do it also, on modern systems as well. So no excuse to try. And so we then really embraced that in 2020, 2021. Kubernetes and Istio became the default for all Air Force and Space Force programs. We also took the U2 jet, which is even older than the F-16s, and we were able to deploy the Platform 1 and DevSecOps stack on the jet in 12 days, build containers to replace the manual use of sensors by the pilot by AI machine learning capabilities, and then fly the jet and demonstrate we could receive over-the-air update of these containers while flying the jet with no impact to the airworthiness of the aircraft, all in 12 days. So that was the first kind of Tesla-like over-the-air update capability for jets, and we're able to really separate the flight control from the AI machine learning capabilities we brought on the jet, all on the legacy jet. So pretty amazing outcomes. And so that kind of led us to really define the three pillars for our modern cyber defense. And so it really embracing modern cloud native concepts. And you'll see, of course, Zero Trust is a big foundation of that. But the first pillar really is called moving target defense. And it's the concept of cattle versus pet. For people that don't know what cattle versus pet is, effectively your traditional virtual machines, you care for them, you give them a name, you heal them when they crash. That's pets. A container, on the other hand, on Kubernetes is cattle. You go behind the barn and shoot it every 4 hours, and you don't care. And so that's a concept we embrace, the cattle aspect, and everything becomes cattle, including your platform layer. And as much as your stack can be automated and have no drift between instantiation, as much as it's become immutable, and we kill containers every 4 hours to do that, that makes it very difficult for malicious actors to retain their foothold on the system. And so really the whole DevSecOps stack is cattle, and that's how we orchestrate everything on top of Kubernetes with containers. Everything becomes code. There's no human in production, no drift in production. GitOps, this concept of GitOps is your source of truth, becomes your source code, where it becomes your crown jewel. And so your infrastructure and your configuration and your policy becomes code. So infrastructure as code, configuration as code, policy as code is your way of doing business. And so that way, if you need to tear it down and bring back up every 4 hours, you can do that with a push button deployment and no human in the loop. And so that automation and that flexibility kind of enables you to be very nimble, and makes it very difficult for a malicious actor to retain their foothold. If the whole stack disappears every 4 hours and go back to immutable state, they will lose everything they've done to get into your stack and laterally move to your crown jewel. So that's how we do business. The second pillar is Zero Trust, where we look at both the identity, of course, of the device being used, so device enforcement, device identities, and then we look at, of course, people and non-person entities, so microservices, systems talking to other systems with strong identities, and then we have the data centricity aspect, where we can label data down to the cell level, so we can be very precise in the labeling of data and fields, so people only get to see what they're supposed to see. All that leverages microsegmentation with whitelisting, and so already the software-defined parameter concept, which is not like software-defined networking, very different technology. SDP came out of the Cloud Security Alliance, and really was brought to life initially by Google but now many companies provide a capability to do that. That gives you that granular microsegmentation using this concept called the segment of one. What that means really is each device and user pair have a dedicated network, and based on the risk of the device and the risk of the user identity and the component risk, you only get access to what you're supposed to have access to. So if I use my personal device versus my government device, I would not have access to the same things based on the device posture. So looking at things like, the state of the device, patch levels, what kind of endpoint protection is running, mobile device management it's running, and things like that. That really enforces the device state aspect. And then when you tie it back to the user using it, to be able to look at strong identities end to end. And so you'll see also how we use Istio as a service mesh to be able to prevent lateral movement between containers. So Istio is able to enforce traffic both on the north-south traffic, but more importantly, the east-west traffic between containers. So container A to talk to B has to be whitelisted, and you limit the ability of a malicious actor to laterally move to your crown jewel by doing so. All right, so that's the second pillar. The third pillar is essential in runtime and is an essential piece of DevSecOps, which is really the continuous monitoring with behavior prevention. And so it's really using runtime capabilities, looking at behavior drifts down to the container level. So looking at each container and see if a container starts doing something it's never done before. That's really the difference between DevSecOps and DevOps. The sec of DevSecOps is not just, hey, I'm going to do some static dynamic code analysis work there. It's basic DevOps stuff. The real advanced security stuff we do is on the runtime side to look at the production environment, and effectively the entire DevSecOps stack runs in production in terms of runtime security stack to be able to look at the behavior and, of course, continuous monitoring and alerting and log and telemetry, centralizing of all these logs to be able to look at not only the basic CVE scanning, but more importantly, looking at the behavior. And then, of course, we also enforce provenance and integrity of the container by signing and looking at checksums of the containers. And so the runtime piece is essential to proactively detect 0 days and behavior that's not normal. Maybe a container starts trying to talk to a container it's never tried to talk to before. Maybe it's running Linux commands it's never ran before. So that kind of stuff would proactively alert the team and kill the container to go back to immutable state to see what's going on. And so that's very very critical as well. Now, when it comes to the layers, we kind of separated the infrastructure layer and the platform layer with the CI/CD pipeline and the service mesh. So that way we can be very nimble and swap layers. So you can be running on a cloud, on a weapon system, on a jet bomber, space system, whatever. And then you're going to put Kubernetes on top. We have multiple distributions of Kubernetes. And then we have the full DevSecOps pipeline on top, CI/CD pipeline, completely containerized. And then what you see on top of that is a service mesh where we have the zero trust enforcement and the ability to centralize log and telemetry. So the application on top inherits pretty much 90% of the NIST cyber controls, and so the team can focus on the 10%. Inheriting all the hardening and security we bring at the bottom layer of the platform and the infrastructure. So as you can see here, we're checking a lot of the compliance boxes, but more importantly, we're bringing a really tightly controlled and secure environment. So teams inherit that and don't have to reinvent the wheel and figure all this stuff out in a vacuum. All right, so here what you see is kind of the ecosystem of the DoD, and by, we had all these teams effectively building things in vacuums, and so when we created Cloud One and Platform One, we're able to empower all these teams to use the centralized enterprise services. And with the lack of talent, of course, it's so essential to do that. Otherwise, you're going to have disparity in maturity of adoption of security concepts and hardening, and a lot of reinventing the wheel. And so for any organization on the planet that's trying to scale DevSecOps, having a centralized platform team to bring all these capabilities to life, it's a whole dedicated job. And so that's why we created Platform One. And as you can see, we're able to use Baby Yoda, which is pretty cool, huh, for a government team. So, all right. So here's an example of a DevSecOps pipeline. Again, we have 1,000+ containers, so that's just a tiny example here. We have many more examples, but what you see is all these tools. If you have to run those as virtual machine, it will be a nightmare to manage and update. And if you have dev, test, staging, and production environments across multiple classification levels like we do, that becomes a nightmare pretty quick per program office. And we have hundreds of programs. F-35 would have, probably 45 of those just by itself. So we automate everything, and we use Kubernetes and containers to instantiate a replica of this stack with a push-button deployment with no drift between environment and classification level. So you have no ability for a human to come and tamper with what's happening in the instantiation of this environment. It's all in code with multiple set of eyes to approve the code changes. You need always 2, 3, or 4 people to come and approve the change based on the criticality of the change. So it gives you a lot of flexibility, but also kind of baked-in security for insider threat and mitigation of risk. So that shows you why we really mandated the use of Kubernetes to be able to orchestrate all this massive stack. Of course, learning is essential. Teams struggle to keep up and see what's going on. So we created a lot of content there. We have dedicated videos on pretty much all of those topics we talked about. On the case study, we have many case studies with SpaceX and others. But we also explain that the culture aspect and what it takes to gain momentum, to educate the leadership, and be able to change the culture of a very large organization like DoD. And so if you check out the learnwithnick.com and of course the software.dev.mil/DSOP/documents, you're going to find architecture documents. You're going to find video content showing like the step-by-step process, and a lot of deep dive on operations, cybersecurity, culture, fail fast, learn fast, don't fail twice for the same reasons. How do you do that in a meaningful way? What kind of metrics do you pay attention to? Something I obviously can't cover here. That's over 9 hours of content on there to kind of guide you through that. It's investing in yourself and your team. I used to give an hour a day. We had 100,000 developers and software team members in DoD, and we were the first one to say, hey, we need to give an hour a day for people to learn. And so that's what we recommend people to do, not only to catch up, but then also to keep up with the crazy pace of IT. So, and then we have a few certification there. We recommend. The Cloud Native Computing Foundation has created a lot of great certification that are beyond just the, hey, I'm going to answer a few questions and I read one book and I can pass it, and this is hands-on stuff, so you can cheat your way in, and it's very good stuff. And the Certified Kubernetes Application Developer, the Certified Kubernetes Security Specialist, and the Certified Kubernetes Administrator, all great options. Of course, the Security Specialist would be for cyber guys, and Administrator would be for people coming from a Linux administrator background. And then the T-Trade Certified ESG Administrator for the Service Mesh is also awesome. So that's stuff that you probably want to invest and take a look at for your career. And also when you hire people, you probably want to try to see either if they already have it or help your team go and learn and pass those certificates. So yeah, thank you. We'll take questions.